This is Mr. Donovan helping you understand potential and kinetic energy, our last two vocabulary words for the term. So first, potential energy, and the definition is stored energy because of an object's position in space. Often gravity will do work on the object as soon as you let go of it. And I'll show you a picture of this right now. So this is a famous rock in Norway, and this rock and this sheep that's standing on top of it has a lot of potential energy. This is because if this rock were to move just a tiny little bit, gravity would do a huge amount of work on it and it would fall all the way down until the water below. Anything that's above the ground has potential energy. For the box labeled picture, you can draw any picture of any object that is off the ground, or that has energy that is stored in that object because of where it is in space. Same for where it says examples. You can list examples, like the rock that you saw in the picture, anything like that. The way you would use potential energy in a sentence is just like this. You would say, the rock has potential energy because gravity will do work on it as soon as it falls. The formula for potential energy looks a little bit scary, but it's not that scary. It's just the force that you need to pick that object up, m times a, mass times acceleration due to gravity, times h. And h here is the height above the ground. But that's just the same as the distance that it is above the ground. In class, I'll show you how this is the same as the formula for work. And because it's energy, which is the same as work, the unit is joules, and that's a capital J. Kinetic energy, which we're going to abbreviate KE, is just the energy of a moving object. Now, moving objects have energy because if a moving object crashes into you, it will do work on you. It will push you, and you will probably travel a distance. For a picture, you can draw a picture here of any moving object you can think of. I'll show you an example right now. So this is a video of Felix Baumgartner, who is the world's highest skydiver.
At least you can see what I can see. Sometimes, yeah, it's considered that's really high. How small you are. I'm going home now.
He just jumped out of the tallest free-falling skydive of all time. So he's actually almost in outer space right now. And as you see, he jumped off the edge of the platform, and he fell away, and he's getting faster and faster and faster as he falls. To use kinetic energy in a sentence, we would say the skydiver, our man Felix from the video, has kinetic energy because he is moving. Anything that is moving has kinetic energy. The formula for kinetic energy, which is right here, kinetic energy is 1/2 times mass times velocity squared. And if you want to know where this formula comes from, I can show it to you, but it'll take a little bit of calculus to understand where it comes from. Okay. The unit for kinetic energy, because it's energy, is also joules, same as potential energy.